Welcome chemistry students to lesson 1 for the week of March 30th. Today we're going to start by just looking at Boyle's law and the relationships between pressure and volume, and then we'll take a look at how to solve equations using Boyle's law. Before we can get into learning some more gas laws, we've already talked about Dalton's. For lesson 1 we'll do Boyle's. Next time when we do lesson 2 we'll talk about Charles' law. We need to be good at identifying units, so telling if we're given a value, is that a pressure, a volume, or a temperature value. The reason this is so important is because especially on end of the week quizzes, you won't be told solve this problem using Boyle's equation or solve this problem using Dalton's equation. You will have to look at your given values and decide the equation that best fits it. So looking at these 12 given values. So this example that I have is 100 kilopascals, kPa, and I've already filled in that that's a pressure, and we give it the variable capital P. So volume, you will know that it's a volume value if it's in the liter, or if it's in the unit liters or milliliters. So I've done this first one, 750 milliliters is my units helping me know that this is a volume, and we use that as a capital V in our math work. So see if you can go through. There's a couple more, I think 3 more volumes in here. Just kidding, 2 more volumes. They're there. All right. So that's how we know if it's a volume value. If we're looking at pressure, pressure can be in the units ATM, atmospheres, or kPa, or mmHg. So if you see a number with any one of these 3 units, you know that's a pressure. So please pause it, or I'll wait for a second. Find the other 4 pressures that aren't already there. I've got these ones, ATM, millimeters of mercury, ATM. Those are other pressure values. And then temperature values. Temperature values can be provided in degrees Celsius, or even better in Kelvin. So go ahead, fill out your table, push pause. As we get to those sample problems at the bottom of this note page, you'll see how we would use this during calculations. Okay. All right. Talking about Boyle's law then. Boyle's law is named for Robert Boyle. I believe the notes packet says Charles Boyle. That's not. It's Robert Boyle, and that's him. Oh boy. He studied the relationship between pressure and volume. And he determined that if you're at a constant temperature, meaning your temperature is not varying, not changing, and only pressure and volume can change, then they have an inverse relationship. That means if you're twice as much pressure, then you divide by 2 for volume. If you double the volume, you cut the pressure in half. So they have this kind of inverse relationship. Sometimes we'd say opposite, but we'd use the word inverse in class. All right. Temperature is held constant, which means temperature is not changing. It's assuming within the same laboratory room, which means only pressure is changing. So right here, you guys have it at the top of your page. We have it down here. It's the first pressure times the first volume is equal to the second pressure times the second volume. That is, mathematically, that is Boyle's law. So practically what that means is if pressure is increasing, volume is decreasing. Pressure is decreasing, volume is increasing. They happen in opposite directions. Graphically, you need to recognize a graph. Okay. Let's see what that looks like. I've got a little animation for you here. Okay. So you'll notice, the first thing I want you to notice is right here, temperature is not changing. It says 300 is your temperature. It's not varying, which means as volume decreases, you see pressure is increasing. Okay. Graphically, go ahead and add this in. Either write it in by hand, that volume and pressure are on your X and Y axis, and then add in this shape, the graph. If you're using the printed notes, then please add that in on the right-hand side of your notes page. But we would expect, given this graph on a quiz or a homework assignment, you'd be able to recognize that that's Boyle's law. Okay. When I double my pressure, my volume is cut in half. Okay, a bicycle pump is a really good example of Boyle's law. You have the phalange or syringe, whatever you want to call it, that you push down on the bicycle pump. So as the volume of air inside of this pump decreases, the pressure of the air increases to the point where it's able to push the air into the tire. Okay, it takes advantage of Boyle's law. In class during the Explore Lab, we used the syringes, those big syringes in class, and we put a marshmallow or a water balloon inside of it, and you were able to see when volume went down, pressure increased. Okay. Again, this graph, looking at that graph, it's a downward slope, that's an inverse curve, so I would say that's Boyle's law. So if you need to highlight that or write yourself a note that you're supposed to be able to match the graph to the gas law. All right. Before we work at the practice problems, each of our classes, which are now quarantined, but each of our classrooms have this poster, okay, for any kind of math problem we've been doing this semester, that you need to find your given, find your unknown, which will help you pick your equation, then substitute solve. So we request, strongly require, whatever you want to say, that you box in your given value and circle your unknown, okay? And by doing that, it will help you pick your equation. And I'm going to show you how to do that over here on my document camera. Hopefully. All right, good. So here we are. It's kind of dark. I don't really know how to fix that, but our Boyle's law sample problems. Before I get to these calculations, I want to show you a memory trick. For Boyle's law, you would have to say Boyle's law is an inverse relationship between pressure and volume. On a quiz, that's something we expect to be pretty automatic. So my favorite way to memorize which variables are in Boyle's law is just by asking Boyle, hey Boyle, which variables do you like? Because he hides them right in his name. Boyle's law, his name hides the pressure, P, and the volume, V. Okay? It's not perfect, but it works. There's no hidden T for temperature in there by any means. So Boyle's law is the inverse relationship between pressure and volume. So if one's going up, the other's going down. Graphically, it's kind of this little sad face. Okay? Pressure and volume, that's how you know it's a Boyle's law equation. On the back of your yellow periodic tables, okay, the Boyle's law equation, it's not labeled as Boyle's for you, but it's this one that only has pressure and volume. Because again, Boyle hides those two letters right in his name. All right, so let's look at our first example. I'm going to grab some colors if it will let me. Example 1 says to compress nitrogen at 1 atm. That is a given value. I'm going to box it in. At 750 ml, that's a given value. I'm going to box it in to 500 ml. There's another given value. So I have found all of my givens. Then it says, what must the new pressure be if temperature is kept constant? So they're asking me for the new pressure. I have boxed in my givens and circled my unknowns. Now, when it says if temperature is kept constant, cross that out. That means we don't care about temperature. We only care about variables. And if temperature is constant, it's not varying. Okay? So now, using the units, just like we did at the top of your notes page, we used the units to figure out what the variable was. We're going to use that same skill down here. Okay? So ATM, I know that that is a pressure. ML, I know that's a volume. ML, I know that's a volume. New pressure, that's a pressure. So by boxing and circling and literally labeling on your quiz, on your homework, on your notes, you know that you need to pick the equation that has 2 P's and 2 V's. So back here under gas laws, all of these different equations to choose from, I know to use that one because it's the only one with 2 P's and 2 V's. Okay? So that's what we mean by saying your givens and your unknowns help you choose your equation. You have to be very careful which numbers you assign as pressure 1, volume 1, pressure 2, volume 2. So there's kind of this magic word at, okay? At means that these guys go together. So I can either call this P and V 1s or I can call them 2s, but they're together. So I'm going to say that this is the first pressure, P1, and this is the first volume, V1. And I'm compressing it to this new volume. So that's V2. They're asking me for a new pressure, so P2. Given unknown equation, so when I substitute, we're going to substitute in those values. P1, I'm going to substitute 1 atmosphere in, times volume 1, 750, equals pressure 2. I don't know what pressure 2 is, so I'm going to plug in an X right there, times volume 2, which is 500. Okay, and it does matter the order that you plug those in, so be careful. All right, combining like terms, 1 times 750 is 750. Great. I need to do the opposite of multiplying by 500. So if I divide by 500, then these sides cancel out, and I only have x left on the right-hand side of my equation. And if we do it to one side, we do it to the other. So I'll divide this side by 500. So 750, let me get my calculator that I finally picked up. 750 times 1 doesn't change, divided by 500 equals 1.5. Okay, now that's the answer I got. You can check very easily if this is a reasonable answer. Okay, so think about this not as a calculator, but as a scientist. What's happening in this question is I'm compressing a gas from this volume to a smaller volume. So volume in this experiment or question is decreasing. And since we have an inverse or opposite relationship in this law, pressure must be increasing. So if my first pressure was 1 and my second pressure is 1.5, that sounds great. That sounds like a very reasonable answer. Okay. For question 2, it says a gas occupies, in fact, you know what, I'm not even going to read it. How about that? I'm not going to start by reading it. I'm going to find any number and unit, box that in, 1 atm, 3 atm. So I found all givens. I'm going to find my unknown. It says, what will be the volume of this gas? So they're asking me to find a volume. So I've done my givens. Now I'm going to label what they are using the units. Liters means this is a volume. ATM is a pressure. They're asking me for a volume. And they're asking me, there's a pressure right there. Okay? So I know to use this equation, right? Now I need to decide which ones go together. So it says at. This volume at that pressure means those are together. What will be the volume if the pressure becomes? So if this is my new pressure, it's what it became. What will be the new volume? Given unknown equation, so substitute. Let's substitute P1. Let me switch my colors here. For my first pressure, I'm going to say 1 atmosphere times my first volume right here, which is 1.56, equals my second pressure of 3 atmospheres, 3.00, times x. I don't know what my second volume is. So I want to do the opposite of multiplying by 3.00 so that I have just x. And I have to do that to this side as well. Okay. I'm going to say 1.00 times 1.56. That doesn't change. Sorry. And divided by 3.00, it's me x equals 0.52. Now I want to check if that's a reasonable answer. Okay, my pressure is going up by a lot. Pressure is increasing, it's tripling. So my volume better decrease, it better be much smaller. And volume went from this to a much smaller answer. Looks like a good. Okay, question 3 is trickier, and there's one just like this on your homework for today. Okay, so I wrote down here, be careful assigning initial and final pressures and volumes here. Okay, the numbers aren't quite as organized for you. So again, before I even read it, I'm going to find my givens. So here's a number and unit that I box in. Here's a number and unit to box in. Here's a number and unit. Okay, and they're asking me what was the original pressure. Okay. An air sample is collected into a 2.5 liter container. That tells me that's a volume. If this gas is brought back to a lab where pressure, so millimeters of mercury, and the balloon becomes this volume, what is the original pressure? So when they say original pressure, that tells me it's the initial P1. So what's the first volume? This is the volume that the balloon becomes, so that's the second or final volume. The air sample was first collected into this one, okay? So again, take a look. An air sample is collected into that first volume. The gas is changed by bringing it to a lab, where the lab pressure is that, and the lab volume, okay? So this one's harder because it gives you volume 1, pressure 2, volume 2, pressure 1. Whereas the other ones we did were 1, 1, 2, 2. So sometimes it does give you the numbers out of order, just be careful, all right? So looking at substituting and solving for this, I'm going to switch colors. My first pressure, I don't know what my first pressure was, what my P1 was. So I'm going to plug in X for original pressure. But I know that it was collected into this original container. That was 2.50 liters. So that's equal to the second volume, which was the volume in the lab, of 775 mmHg, okay? And the volume became this second volume of 1.75, okay? So I can tell my volume is decreasing in this problem. So my pressure better be increasing, okay? My pressure should be bigger than that one. I might have just said that backwards. Let me think about this. Sorry, guys. All right, I want to do the opposite of multiplying by 2.5. So we're going to do that. Just dividing by 2.5. So let me scoot this to the side so you can see my calculator. But I'm going to multiply. It's not showing up. Here we go. Multiply my top values. So 775 times the top, 1.75 equals, divided by the bottom, 2.50. Okay, gets us 542.5 is our X. Okay, and this is where I got confused. Let's ignore what I said there. Okay, so my first volume was this, and it changed to that. Okay, my first pressure was this, and it changed to that. Your homework is very similar to this. You're going to have a couple calculations. We'll also be asking you some concept questions like we did up here on the notes. Okay. There is a video tutorial for the homework if you think you need help, so check Canvas or YouTube for that as well. Thanks.